All right, we're going to put it all together and do ellipses and hyperbolas, every type of ellipse and hyperbola. And we're just going to have general equations, and we're going to have to figure out whether they are ellipses or hyperbolas. So let's go ahead and do a quick review of ellipses. But now we're going to have ellipses with center actually h comma k instead of just a center 0, 0. So the first kind of ellipse we might see is sort of this oval that is longer in the x direction. We would say that this has a horizontal major axis. If it has a horizontal major axis, then the equation is going to look like so: x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now a squared is going to be the big base, and b squared is going to be the small base. For the foci, we're going to end up having h minus c comma k and then h plus c comma k, where c is going to come from the equation c squared is equal to a squared minus b squared, which you can think of as the big base minus the small base. So I'm going to draw this ellipse. We have the center h comma k. We have this y distance to the edge, which is going to be b. That's the thing underneath the y, right? And then we have this x distance a, right, which is underneath the x squared. We have the foci, which I'll label h minus c comma k and h plus c comma k, and I'm going to label that distance c from the center to the foci. All right, let's go ahead and take the second type of ellipse. This is where we have one that is stretched out in the y direction. Here we would call this a vertical major axis. So the equation looks very similar to the last one. The only thing that's different is that I have an a squared underneath the y and a b squared underneath the x, which means my big base is underneath the y, my small base is underneath the x. So my foci are actually going to be h comma k minus c and h comma k plus c, where c squared again is equal to a squared minus b squared, or the big base minus the small base. And that's how we figure out where that c is. Let's go ahead and draw this to see what it would look like. We'd have the center h comma k. We'd have the foci coordinates h comma k plus c, right? It's bigger in the y direction. That's why we're adding c to k instead of h. And then h comma k minus c, and then I've labeled those a, b, and c on that picture. Go ahead and pause the video if you want to copy that down. Okay, let's go ahead and take a look at hyperbolas generally. Let's say we have a hyperbola with center h comma k, no longer just center 0, 0. So we're going to have two different looking equations. The first one, I'm going to have x first, so it's going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. The other one is almost the exact same thing, except we switch the y and the x's. So for the first one, my foci are going to be along the x direction, so I get h minus c comma k, h plus c comma k. For the second one, the foci are actually along the y direction, which means I'm going to have h comma k minus c, h comma k plus c, right? So I add c either to the x or the y, depending on which one comes first. For all of these hyperbolas, I always have the equation that's true, that c squared is equal to a squared plus b squared. That is, I'm going to add the two bases together and set it equal to c squared and solve for c. Okay, so I'm going to kind of draw sketches of these hyperbolas so you can see what they look like. Obviously, I draw my box, I draw my asymptotes, right? And because this first equation has x first, I'm going to draw this hyperbola sideways, right? The center is going to be right where those two diagonal lines cross, and then I'm going to draw my foci. I'll have h plus c comma k and then h minus c comma k on the left side. Okay, so we'll have a distance of a here, right, that distance in the x direction, and then a distance of b in the y direction, and then a distance of c between the center and the focus. Okay, same sort of thing for the one that's up and down, right? Y is first, so it's opening to the up direction and the down direction, and I'll label A, B, and C as well. So A is the distance in the y direction. You can see that a squared was actually underneath y. B is the distance in the b direction, right, because it was underneath x. And then we have that c between the center and the foci. Always remember that the foci get scooped up by the hyperbola, which is one way that can help you remember how they look. Let's go ahead and take an ellipse that has two foci that are given. The two foci are -5, 1 and 3, 1. So we no longer have a center 0, 0, so we're going to have to figure out what that center is. We also have the sum of the focal radii is equal to 16. Recall that 2a is equal to the sum of the focal radii and the difference of the focal radii when we're talking about hyperbolas, but for now, we're just going to talk about the sum of the focal radii. So 2a is equal to 16, which means a is equal to 8, and a squared is going to be equal to 64. So we're going to start drawing this, just a quick sketch where I'm going to label where my foci are. They're at -5, 1, and 3, 1. So my center needs to go right in the middle, and I can kind of visually see where that is going to go, but I can also use the midpoint formula to figure out where the center is, because it's always right in between the foci. So I would add the 2 x coordinates and divide by 2, add the 2 y coordinates and divide by 2. And eventually I would get the coordinates -1, 1. That's my center. Okay, because I have my center, I can start getting an equation for the ellipse. I know this is an ellipse. That is not like that vertical skinny one, but this horizontal one, right, with the horizontal major axes, because my foci are in a horizontal relation with each other. So I'm going to do x first, and it's going to have the bigger number under it, which means it's going to have a squared underneath it, because a squared for ellipses is always the bigger number. And then I'm going to put my center coordinate, so it's it's x minus h. Since h is -1, it would be x plus 1 squared, and then y minus k, which is 1, so y minus 1 squared. And then I just need to figure out what b is. So c is equal to 4 because it's the distance between the focus and the center. That's 4 units. So c squared is equal to 16. 16 is equal to 64 minus b squared. Therefore, b squared is equal to 48, and I'll put that underneath my y minus 1 squared, and that is my equation for the ellipse. Moving on to now a hyperbola. I'm given the same two things. I'm going to have 2 foci as well as now the difference in the focal radii. So suppose that my foci are 0, 4 and 0, 10, and the difference in focal radii is equal to 4. So I know that 2a is equal to 4, so a is equal to 2 and a squared is equal to 4. So let's go ahead and just map that out right away. And then we're going to sketch where our foci in relation to each other are. That was kind of a weird order of saying that. But anyway, we're going to graph these 2 foci. They're at 0, 4 and 0, 10. So if you graph these, you can see that they're in a vertical relation with each other, which means since my hyperbola is going to scoop up those foci, right, that it's going to be a sort of up and down hyperbola, and y is going to be first. But first, let's go ahead and find the center. The center is the midpoint between the 2 foci. So I can use the midpoint formula, or I can just visually look at it. It's up to you. But we end up getting 0, 7 as the midpoint between the 2 foci, which is our center. And I also know that my distance c between the center and the focus is equal to 3. I can see that on my graph. So I know that I'm going to use the form of the equation that has y first. So I'm going to use this equation with y minus k coming first. And I know that the center coordinate is 7 for k, right? And I know that the center coordinate for h is going to be 0. So I'm going to plug those in. So I put in 0 with that x and then 7 with that y. And then I'm going to put 4, which is a squared, underneath whatever is first. In this case, it's y, so I'm going to put a squared underneath y. So then I'm going to find b squared by setting c squared equal to a squared plus b squared. 9 is equal to 4 plus b squared, and then b squared should be equal to 5. And then I just kind of remove that 0 because it's extraneous in my equation, and I get the following equation as you see there. So now we're going to take a look at what if they just give us sort of a unclear equation. We don't really know what shape it is. How do we figure out what shape it is, and how do we kind of get it into standard form? So really with standard form, we're always completing squares, right? And we're going to complete squares with pretty much all conics. So the first thing I'm going to do is I'm going to complete the square in x, which ends up as x plus 1 squared. And then I'm going to try to complete the square in y. But the very first thing I'm going to do is I'm going to divide by 9 because I'm not going to want anything next to the y. So I get x plus 1 squared over 9 is equal to negative y squared plus 2y. And then I'm going to bring the y squared back over and the 2y back over. I made a mistake there. It should be minus 2y and not plus 2y. I'll correct it later. And then we have x plus 1 squared over 9 plus y, it should be minus 1 squared over 1 is equal to 1. I just added that over 1 just for ease, so it looks very similar to the standard form. This is an ellipse, right, because I have a plus sign in between the x plus 1 squared over 9 and the y, it should be minus 1 squared over 9. And I also know that it's this kind of ellipse, right? I have a bigger number underneath my x, which means it has a horizontal major axis, or it's longer in the x direction. Okay, so here you see that I'm going to finally correct that. It should be minus 2y and then y minus 1, because when I brought that 2y over, it should have been negative 2y. So my center coordinates are negative 1, whatever makes that x plus 1, 0, and 1, whatever makes that y minus 1, 0. I also know that c squared is equal to a squared minus b squared, which is 9 minus 1, which is equal to 8. Therefore, c is equal to plus or minus 2 rad 2. So the foci coordinates will be negative 1 minus 2 rad 2, 1, and then negative 1 plus 2 rad 2, 1. So I'm going to graph this ellipse as a last step. And the first thing that I'll plot is the center here, okay? And then I'm going to go 3 out from the center in the x direction, 3 out in the center in the other x direction, and then 1 up and down in the y direction. I went a little bit too low here, but I'm going to correct it in a second. This is wrong. That was 2, and I was wondering why my rectangle looked super weird. And then I suddenly realized, oh, that's wrong. Let's go ahead and draw a dotted line, just 1 away from the center. And then I draw my ellipse, and then you can kind of just roughly sketch. If you have a calculator, you can figure out exactly where they are, but you're going to roughly sketch where your foci are going to go. So let's go ahead and take an example where we have a hyperbola. Okay, well, actually, first, we don't know that it's a hyperbola. But you can kind of see that since it's 9x squared minus y squared, your brain might immediately realize, okay, this is going to be an ellipse because I'm subtracting x squared and y squared. So I'm going to bring y squared, 6y, and 9 to the other side. And it happens to be an already complete square. So then I'm going to divide everything by 9 so I can get x squared minus 2x by itself. So I get x squared minus 2x is equal to y plus 3 squared over 9. I'm going to add 1 to both sides to complete the square, and then I get x minus 1 squared over 1 minus y plus 3 squared over 9 is equal to 1. This is the standard form for the hyperbola, and I have x first. So I'm going to look at my standard form, and it's going to be this form where I have this sort of sideways looking hyperbola. So I'm going to take a look at what c squared would be equal to. I'm going to add the two bases to figure that out. So c would be equal to plus or minus rad 10. The center of this ellipse here is whatever makes, that x portion 0 and the y portion 0. So it would be 1, negative 3. So the foci are going to be 1 minus rad 10, negative 3, and 1 plus rad 10, negative 3. So I'm going to draw this out, kind of making a graph here. I know that my center is going to be at 1, negative 3, so I'm going to plot that point first. I actually plotted it on the wrong side, which I just realized. It should be on the other side. But anyway, the rest of this will be the same. So I'm going to go 1 away from the center in the x direction and 3 away from the center in the y direction because there's a base of 9 there. I'm going to draw my dotted lines to make a box, and then I'm going to draw more dotted lines to make asymptotes, and obviously this whole thing should be on the other side of the y-axis, but it's okay. And we're going to draw a sideways looking hyperbola, right, which is going to scoop up our two foci, which are going to be here and there. And sorry about that very large mistake of putting that center in the wrong location, but everything else is correct, so you should be fine. Have a great day and good luck on your homework.